All right, so we're on 1.2 now. We're talking about linear measure and segment addition. I'm going to try and go through the problems kind of quick, so if you ever need to pause, go ahead and do so, but I just want to do that so that the video isn't too incredibly long. Okay, so first of all, we got a few definitions and kind of just general information. Measuring segments, the distance between 2 points is the length of that segment. So the length of segment AB. And notice I'm putting a segment above it, not a line. So the line has arrows, segment does not have arrows. So the length of AB can be written as just AB with no label on top. Okay? So if you look at the picture over on the right, we've got AB, which is 1, 2, 3, 4 units. Or how the other way you can find a measure is just taking the far right minus the far left. So that would be 3 minus negative 1. And minus negative becomes plus, which is also 4. Okay? So that's measuring segments. Congruent segments, the word congruent kind of means equal. Okay? Congruent means they have the same length. They're not the same segment, but they're equal in length. Okay, so if AB, so the length of AB, equals the length of CD, then these segments are congruent, and we would write that like this. Segment AB is congruent, so equal sign with a little squiggly, congruent to segment CD. Okay, so you can kind of see that in the picture. 1, 2, 3, 4. 1, 2, 3, 4. So they're equal in length. Okay? Congruent. And then finally, segment addition postulate. This is a postulate. It's kind of like a rule. Okay? So a segment addition postulate just says if a point is between two other points, then the part plus the part equals the whole. So if A, B, and C are all on the line, like in our picture, 1, 2, 3. Okay, if they're all on the line and B is between A and C, then we can take the part, so the part plus the part equals the whole thing. Okay, so what we would say is AB plus BC equals, oops, not CD. AB plus BC equals the whole thing, AC. Okay, so AB plus BC equals the whole thing, AC. All right, so that's kind of how we're going to use segment addition to solve some of this stuff. Okay, so a couple of quick examples here. We've got PQR, all on the same line. So what we have in our first picture, I'm going to use pink for number 1. Use this picture. We've got PQ is 9. I've got QR is 28. And it wants me to find PR. Well, PR is the whole thing. Oops. PR is the whole thing there. So to find the whole thing, I take the part, 9, plus the other part, 28. To get the whole, and that's going to be 37, and there's our answer. Okay, so kind of the same deal here on the bottom. I've got QR this time, so on number 2 I'm going to use blue there. QR is 17, and then it says PR, so the whole thing is 21. So now that we have the whole thing and we're missing a part, now we kind of want to use the same addition postulate, but we might have to subtract in the end. So really, how I can set this up is I'm going to go, the part that's missing is PQ. So PQ plus 17 equals 21. Well, I want to find PQ, so I just have to subtract 17 to find what that missing part is. And so PQ is 4. Now, some of you are probably thinking, well, I know there's 4 things left, so I know that's 4 right away. And that's fine. I'm just kind of showing you where you should be thinking, but If you can get that without doing the subtraction, that's fine. All right. So we're going to do a couple examples here, numbers 3 and 6 here. If you want to try those before I do it, you can pause it. But what we're doing here is the same thing, except we have a little algebra to do. So e.g., the whole thing is 71. So I'm going to take the part plus the other part equals the whole. So 8x minus 17 is one part. Adding 5x minus 3 is the other part, equals the whole thing, which is 71. And this is where we go back to algebra and using combined like terms, getting the variable by itself on one side. So I've got 8x plus 5x. Those are like terms because they both have an x. It's 13x. And negative 17 minus 3. I'm going to use my calculator with the negatives just to make sure. So negative 17 minus 3, negative 20. And that equals 71. So now we go ahead and do whatever we can to get x by itself. So we always sing a song in algebra. Get the x by itself, doo-dah, doo-dah. So to get the x by itself, I'm adding 20 to get rid of the negative 20. And I get 13x equals 91. And then I divide by 13. So again, use your calculator if you need to. That ends up being 7 for x. Okay, find the value of x. Make sure you read the directions, because if it told you to find something, you might have to go ahead and plug it back in to find something, but in this case we didn't have to. Okay, so let's go ahead and do the same thing on number 6. But actually, no, we're going to do number 5. Sorry, I switched up on you. We're going to do number 5 because I want us to find JL after we find X. Okay, so in this case, again, I have the part, and JL is the whole. Okay, 5x plus 2. That was terrible. Oh well. So here we go. 27 is the part plus 3x minus 1 equals the whole thing, 5x plus 2. Now we go ahead and combine like terms where we can. So I've got 27 and minus 1. So 3x plus 26 equals 5x plus 2. Now in this case, I have x on both sides. So I'm going to make sure to get x on only one side. And what I usually do is I get it to the side that's going to keep x positive, but that's kind of up to you. So I subtracted 3x, and I've got 26 equals 2x plus 2. And then I subtract 2 to get x by itself. 24 equals 2x. And then divide by 2, and I get x equals 12. Okay, but look at the directions. This time the directions say find JL. So in order to find JL, I need to find KL first, and then add them together. So KL equals 3 times 12 minus 1. So I'm plugging in x for what it equals. And so that gives me 3 times 12 is 36 minus 1 is 35. And so if I look at these two things, I'm going 35 plus 27. So JL equals 27 plus 35, which equals, do the math, that's 62. And we're done. Okay, that's our final answer. All right, so if you want to try these two examples, go ahead and do so, and we can talk about those in class. But let's go to the back side now. I'll come back to number 7 at the very end if you want to look at that one. But the midpoint end of a segment is another important thing we need to talk about. So again, B is between A and C here. But this time it's a midpoint, meaning that it splits it up into two congruent parts. So AB and BC are the same because it goes right down the middle. Okay? So the midpoint of a segment is the point that divides a segment into two congruent segments. So what that means is, if you don't know what the whole thing is, if you don't know the whole measure, you can set the two parts equal to each other because they're congruent. So a line ray or segment that intersects a segment at its midpoint is said to bisect the segment, and it's called a segment bisector. Segment bisector. So when something says bisection, it means it's splitting it up into two congruent parts. Okay? So when you look at these two words, midpoint and segment bisector, those mean the same thing. It's splitting it up into two congruent parts. It's splitting them up so that they're equal. Okay, so in the diagram here, I've got B is the midpoint of AC. Sorry, my phone's ringing. I'll call them back after this. And line L is a segment bisector. Segment bisector of AC. Okay, so if Q, so we're going to do two examples again, number 8, and we'll go ahead and do number 10 as well. Okay, so let's look at that here. Number 8. So Q is the midpoint of PR. Find the value of X. So I've got to go here and here, give me the whole, but I don't know what the whole thing is, so I can go ahead and set those two things equal to each other. Okay, so since it's the midpoint, I can go 7x minus 16 equals 4x plus 2, and then I can go ahead and get x on one side of the equal sign, get 3x minus 16 equals 2, and so now I'm getting the x by itself, doo-dah, and I get 3x equals 18. So divide by 3, I get x equals 6. Take a look at your directions. Make sure you're not supposed to plug back in, and that's our final answer for x. Okay, so our last one here, we've got number 10. R is the midpoint of QS, and then it says find QS. So we got to plug it back in at the end once we find it. But since it's the midpoint, I can set those equal to each other. So 2x plus 16 equals 5x minus 17. And again, this is where you can kind of subtract 2x or subtract 5x either way. I'm going to subtract 2x to keep that positive. And then, so I've got 16 equals 3x minus 17. Get the x by itself, doo-dah, and I get 33 equals 3x. Divide by 3, x equals 11. Now, that's not my final answer. I usually box my final answer. So I need to make sure to now plug x back in to find those parts. So I'm going to go ahead and plug it back in for 2x plus 16. So it's going to be 2 times 11 plus 16. That's 22 plus 16, which is 38. And if I know that that's 38, so looking at a picture, I've got this is 38, and I've got this is 38. Put them together, and that's going to give us QS. So QS is 38 plus 38, which is 76. And we're done. Okay, so if you want to go ahead and get started on things, we'll probably just talk about number 7 in class. But go ahead and get started on the knowledge check. And again, email me on Canvas or whatever it might be to ask questions if you have them, and I'll try and get back to you as soon as I can. Or again, make sure you have those questions in class as well, and we can discuss. All right? So go ahead and get started, and I will be talking to you soon. Peace.